Hello, ladies and gents. We are going to continue today talking about how do we solve equations with that highest exponent of 2, what we call quadratic equations. Not all quadratic equations can be solved using square roots, the method that we learned the last class session. So today we're going to talk about why is it that not every equation can be solved algebraically using square roots, and what do we do when we can't use square roots. If you want to log on to Agile Mind, I am going to just use a couple of their slides in Agile Mind. We are still in, if you go to my courses on the top, we are still in Unit 8. So drop down arrow next to Unit 8. Drop down arrow next to topic 22, and we are down here lesson 10 using the quadratic formula. You're also going to want access to your school calculator on your computer. That would be ideal. Otherwise, whatever calculator you have at home or built into your computer, you could also use this one up in the top corner of your Agile Mind. And your workbook. Of course, you're going to need your workbook. Today, we are going to start on page workbook 305. And if you don't have your workbook at home, if you are on Agile Mind, you'll see activity book right here. Same thing, page 305. So while I flip around the screen, I want you to go ahead on page 305. It should look exactly like what you see here on my screen. And the question is, if we graphed, or we did graph this equation, 2x squared plus 3x minus 3, same graph, notice, and the x-intercepts were found using that method we saw in the calculator, the second calc, left bound, right bound, find them. So they found the x-intercept on the left here, x-intercept on the right here, and you'll see the answers that they came up with. The question is, are these x-intercepts representing exact solutions? Are those approximate? And why do you think what you think? Are these decimals here for these x-intercepts, are they considered approximations or are they exact? You think about that. I am going to flip around my screen so I can work in my book here. Okay. Here we go. Now, some people would argue that these are not exact solutions because they are not whole numbers or integer numbers, something like 2, 3, 4, -5, -8. Well, keep in mind that exact answers do not have to be integers, numbers that we count with. Exact answers can be decimals. They can be things like 1.5, -2.652. Those are exact answers as well. So does that mean these are exact answers? The answer is actually no. Now, this is not something you would necessarily know right away, but your calculator screen has a maximum capacity for how many digits it can have in any number. And when your decimal is this long on your calculator, whether it's negative or positive, when it's this long, your calculator ran out of room. It can't fit any more decimal numbers in here because otherwise it's going to hit the y equals. The calculator ran out of room and it just cut off the decimal. With the fancy name for cutting off a decimal is called truncated. So your calculator is actually showing approximated solutions. Your calculator is actually showing approximated solutions. So how could we find the exact solutions? Now, again, I know many of you are thinking, well, 0.686, that's close enough. Who cares about exact? As you move on in math, you will see more reasons why that exact answer is going to be helpful. It actually will make your life easier, believe it or not, in some cases. And also for those of you thinking about going into a career that would utilize math, if you make approximations in your calculations too early, then you may be messing up your ultimate product in the end, whatever that happens to be. Whether you are working in computer programming, you are in engineering, whatever your career path happens to be, making approximations early on can mess up your intended outcome of whatever you're working on. So technically, these are approximations, and I know that because of how long these decimals are. So again, how do we come up with exact ones? Well, I'm going to go back right up here to this equation, and I'm actually going to copy it down here again. And we're going to think about what we did last lesson, which was solving using square roots. See if we can apply that to this equation we are working with now. Okay, we know that to solve by square roots, we had to isolate our x squared term first. We wanted to get x squared by itself. So I'm going to add 3 to the other side. That gives us 2x squared plus 3x, those cancel, equals 3. maybe some of you are noticing this looks a little bit different than the last lesson. And the reason is we have what we refer to, and you'll see why we refer to it as this very shortly. We have what we call a B term. We have this term that has this x by it. When we were dealing with square roots, we had x squared, and that was our only variable. With square roots, we had things like 2x squared minus 3 equals 0. May have been some not so pretty numbers for square rooting, but we could add 3. We could divide by 2. And 3 divided by 2 is 1.5. And then to get rid of that squared, we could square root. Whatever we do to one side, we do to the other. We know we get a plus or minus. I have my calculator off here to the side. I have no idea what the square root of 1.5 is off the top of my head. But using my calculator off to the side, I know it's approximately positive and negative 1.22. Notice the difference here, though. This guy does not have a B term. This one has this B term. A B term is the term attached, the term with just an X. Notice this X does not have a squared, but a B term is the term that is an X. Square roots do not work with B terms. No square roots for B terms. So if we have B terms, sorry, we can't use square roots. We need another way of dealing with it. And that method is what we appropriately call the quadratic formula. Quadratic formula because it only works if you are dealing with a quadratic an equation whose highest exponent is 2. So on Agile Mind, I'm just flipping to page 3, or you can fast forward in the arrows to number 3. This right here in the middle of the screen, this beautiful, beautiful formula is what we call the quadratic formula. So questions I'm sure running through your head. Do we have to memorize it? The answer is for this year, no. In geometry next year, you may have to. By the time you hit Algebra 2, yes, you will have to have it memorized. Now, for those of you who know Pop Goes the Weasel, you know that annoying song if you have a Jack in the Box when you crank it and goes da-dun, 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 that song. There is a widely known favorite of algebra teachers, a way of reading or remembering this quadratic formula by singing it to the tune of Pop Goes the Weasel. So I want you to excuse me for my singing voice, but I want you to look at my cursor and I'm going to sing and point to which part of this quadratic formula I happen to be singing. So here we go. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So for those of you who know Pop Goes the Weasel, fits perfectly, but for now, for this year, you just have to get comfortable using it. And I promise you that it is way easier to use than what you probably think it's going to be. It looks a whole lot uglier than it actually is. So I want you to go ahead and copy that down into number 1 underneath core activity in your workbook. Copy down that quadratic formula right here. You'll notice you have all of this stuff up through x equals. You just need to type in, you need to copy in that quadratic formula. For those of you who don't have your workbook, please, you write it down on whatever paper you are taking notes on. Okay, so here's where we see why we call this number in front of x the B term. A, you notice all the way over here on the left, A is the number in front of x squared. A just represents number in front of x squared. B represents the number in front of x. So A, B, and C are actually not variables at all. They just represent numbers. And C is our constant. C for constant is our number that stands alone. Number that stands alone. So what I was saying up here earlier, this 3 is part of my B term because 3 is in front of x, and the number in front of x is our B, A, B, C. Now be really careful. A lot of people think, in a quadratic equation, A is the first number I see, B is the second, C is the third. Not always the case if they're not written in the correct order. So don't remember it that way. Remember, A is in front of x squared, B is in front of x, C stands alone, or C is the constant. So keeping that in mind, I am going to go down here to number 2, and we're going to solve this equation. We realized we can't use square roots because we have a b term, so we're going to instead solve it using the quadratic formula. Something we'll note, in order to use the quadratic formula, you must be equal to 0. Must equal 0 to use quadratic formula. Must equal 0 to use quadratic formula. If you are not equal to 0, you are going to have to add or subtract things all to the same side in order to make your equation equal to 0. So I like to label first. What's my A? What's my B? What's my C? So A is in front of x squared. So our A happens to be 2. B is in front of x. So our B happens to be 3. And C is the number that stands alone. Now be really careful with this one. That negative is going to go with it. C is going to be -3. So let's fill this in. Following the quadratic formula, we have x equals, now I also like to think of this not as -b, but the opposite of b. Opposite of b, because what if you say your b is -2? Does that mean you don't have to do anything to it? No, I want the opposite of that. So our opposite of b, well, our b is 3, the opposite is -3. Plus or minus the square root. Now be safe, whatever you plug in here, please, please, please use parentheses. I need b. Our b is 3. So I have 3 squared minus 4. That goes nowhere. A is 2 in parentheses. C is -3 in parentheses. Now notice this fraction bar. It is underneath everything. So fraction bar under everything, 2, and using parentheses A, which happens to be 2. Now I'm going to switch back over to AgileMind, and I want you to watch. I am going to go to, let's see if this loads here. Here we go. I'm going to hover over here. I'm going to go to page 5. I think this is really nice to see. You obviously just saw me plug numbers into the quadratic formula for problem number 2 in your workbook, but AgileMind does a really great way of showing how those numbers get plugged in. So I just want you to watch the animation of the screen and how they move numbers into the correct position. And you should notice now that what they have on, what AgileMind has on their screen is exactly what is currently in your workbook in number 2. So here's where you're going to need your calculator. Simplifying this expression is way easier than you actually think it should be or is going to be. And it becomes so much easier when you use your calculator. So what do we type in our calculator first? Can't type it all. Sorry, you're going to have to do this in pieces. So the first thing that you are going to type in your calculator is everything that I just circled in green. I realize it's hard to see on that screen, but what you should notice is that what I circled in green, I'll go back there for a second. What I circled in green does not include the square root. It is everything that is under the square root. So as long as I copy into my calculator everything that is under the square root, parentheses and all, then we are good to go. So I'm going to double check. That looks like everything underneath the parentheses, or underneath the square root, including the parentheses, I get 33. Awesome. Cool. Moving back down here. That means I have x equals, I still have this -3 right here. I've done nothing with it. Plus or minus, never touch the square root. But I know that I got 33 when I typed all of that in. So 33 right there. And the second thing that should happen is this denominator. Now, hopefully, you don't need a calculator to check what you get out of that denominator. We all know that 2 times 2 is 4, so I have a denominator of 4. Sorry, that's hard to read there. That is a 4. They don't give you a lot of space in these workbooks. Hopefully, this is looking so much better than it was before. So what to do from here? Well, 33 is not a perfect square. It's not like 36. The square root of 36 is 6. The square root of 33, not a perfect square. Because it's not a perfect square, technically, there's no more we can do. This is considered the exact solution. This black pen is not working very well. Here we go. This is considered the exact solution. If you cannot take the square root and get a pretty number like 2, 3, 4, 5, then you're done. That's the exact solution. However, sometimes you may want the decimals. So how do we come up with the decimals? If we want to come up with the decimals, the next thing we do, and I'm going to move down here, and the next thing we do is type in the square root of 33. We have to figure out what the heck the square root of 33 is. So going here, I'm going to go square root of 33. I'm going to have to approximate because that's big and ugly. It's approximately 5.74. So the square root of 33 is approximately 5.74. So we still haven't used the -3 in front, still haven't used the plus or minus, but we did square root and we got approximately 5.74 all over 4. Again, look at where we started, look at where we are now. It's not hard using the quadratic formula. It's just a lot of numbers that you start with. Okay, so how do we add and subtract at the same time? Well, really, honestly, you guys, we can't. So we're going to split this into 2 problems. One problem in which I add the 5.74 and then divide by 4, and one in which I subtract the 5.74 and then divide by 4. So simplifying, and be really, 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 really careful. And I'm going to make a note here. Hit enter in your calculator. After you add, after you subtract, whatever it happens to be, hit enter before you divide. So -3 plus 5.74. Watch, I'm going to hit enter. And then I have to divide by 4. And we get 0.685. And I'm going to copy that down into my book. You should do the same, 0.685. Our next one was -3 minus 5.74. I'm going to hit enter before I divide by 4. And we get, in this case, -2.185. Our 2 solutions, our 2 x-intercepts, our 2 zeros, whatever you want to call them, because remember there's more than one name, are 0.685 and -2.185. Not very pretty numbers, but again, this would be exact. Because 33 is not a perfect square, that would be our exact solution. This one would be our approximate solution. Approximate solution. Now, it did say compare those to the solutions in the opener. You will notice -2.186. We got -2.185. Really the same thing. We did some rounding. 0.686, 0.685. Again, really the same thing. But when we square rooted that 33, we had to do some rounding. So if you're like, dude, Mrs. P, I got it, then what I'm going to say is go ahead and stop the video if you got it and go on to the next step that's listed out in Canvas, which is some homework. If you want to stay on, though, I highly encourage it. I'm going to do 2 more problems with you here for A and for B. So like I said before, I like to label my A, B, and C first. So going to for A, I know A is the number in front of x squared. So for us, A is equal to 3. B is the number in front of x. Now notice we don't have a coefficient, but remember we don't ever really write ones. So our B is -1. And C is the number that stands alone. Don't forget that that negative goes with it. So our C is -5. So now that we have A, B, and C, now it's just a matter of plugging it into that quadratic formula. So here we go. X equals, again, I like to read this as opposite of B, because if I said -B, I'd look and say, oh, it's already negative. I don't have to do anything. No, I need to do something. I want the opposite of B, so we need +1. Plus or minus the square root of, don't forget your parentheses, I need B. B is -1 squared. Minus, whoops, I drew a plus sign in there, minus 4 A is 3. C is -5. All over 2 times our A, which is 3. First thing in your calculator should be everything underneath that square root symbol, parentheses and all. I'm not going to bring up my calculator this time. I'm using my calculator off to the side so that you can try it on your own as well, and then verify your answer with mine. -4AC. And if you type in everything underneath that square root, parentheses and all, you should get 61. You should get 61. So we are at x equals 1 plus or minus the square root of everything under those parentheses gave me, or under that square root, gives me 61 all over multiply, because you don't need a calculator for that. 2 times 3 is 6. Now, if I wanted the exact answer, I'd be done, because the square root of 61 is not a perfect square. Again, we would be done at that point. Might as well label it. That is our exact form. Will they always be things that we can't square root? No. Sometimes you'll get nice answers, and that's a good thing. But in this case, not pretty. I'm going to keep going, though. And my next step to get the approximate is to square root 61. So we are now, I'm going to move here, x equals 1 plus or minus the square root of 61 is approximately 7.81 all over 6. Now here is where we know we can't add and subtract at the same time. So we're going to turn this into one where I add 7.81 and divide by 6, and one where we subtract 7.81 and divide by 6. Again, when you type in your calculator, I'm going to go with the 1 plus 7.81, hit enter, and then divide by 6. You should get 1.47. If I round, is one of my solutions, one of my x-intercepts. And when we subtract 1 minus 7.81, hit enter, divided by 6, you should get -1. I'm going to copy the whole decimal, 135. Our two x-intercepts, 1.47, -1.135. Now, Mrs. P, how do I know that that's right? I am going to, actually, I could do it on here. I'm going to actually quickly throw this one into my graphing calculator and my y equals. We got 3x squared minus x. I'm just typing in the original equation in 4a minus 5. We're already equal to 0. I may have messed with my graph, so I'm going to just make sure it's on standard. And think about the answers we got. 1.47. If I estimate, looking right there at where we cross on the positive x side, yeah, that looks like it definitely could be about 1.47, because that's about one and a half. Our other answer was -1.135. And if I go all the way to the left, yep, that looks about right. I could also do my second calc, 0, because solutions, x-intercepts all mean the same thing. Go to the left of one of them, hit enter. Go to the right, hit enter, guess. Hey, that one on the left is -1.135, as we can see in the calculator, which is very close to what we got when we did this by hand. I could go through and use the calculator to find the x-intercept on the right, but we are going to see it's 1.47. So if you want to stick with me, I'm going to do one more example, 4B. Again, if you are okay to go work on the homework, then you do that. If you want one more example, then stick with me. There's not a whole lot of room, so I am just going to copy 4B over here on this side. -6 minus 2x plus x squared equals 0. Now, I think this one is a really great one to do, because you notice the order is a little messed up. So remember, a is the number in front of x squared. So if I focus on my x squared, see no number in front actually means we have a 1 in front. So our a happens to be 1. B is the number that is in front of x. Our b happens to be -2. And c is our constant, the number that stands alone, so our c is -6. So plugging it into the quadratic formula, we have x equals the opposite of b. So the opposite of our b is +2, plus or minus the square root, make sure you make that square root big enough, using parentheses, b, which is -2, squared, minus 4, parentheses, a, which is 1, parenthesis C, which is -6, all over, make sure that division symbol, that fraction bar goes all the way back to the equal sign, all over 2 times A, which happens to be 1. Again, oops, there goes my computer. I'm going to use my calculator on the side again. And the first thing that's going into our calculator should be everything here underneath the square root. Don't type that square root symbol, just everything underneath. Now, if you're thinking, why don't we type the square root symbol? Well, we want to find out if we're going to get a perfect square underneath. We want to find out if this is going to give me a messy answer like the decimals we've been getting, or something a little bit prettier, if you will. So I typed in everything that I just circled here in blue. I still have the 2. I still have the plus or minus, still have the square root. And when I typed that into my calculator, I got, underneath the square root symbol, 28. Next thing we should be doing is multiplying in the denominator. 2 times 1, don't need a calculator for that, is 2. Now this, again, square root of 28, not a perfect square. This would be exact. But I'm going to keep going, and I'm going to go to the approximated form. So next thing for the approximated form would be to actually square root 28. So that means we still have, I'm going to go up this way, x equals 2 plus or minus square rooting 28. We got 5.29. all over 2. And here's where we're going to split this apart. We're going to do one where we add 5.29 and then divide by 2. And we're going to do one where we subtract 5.29 and then divide by 2. So going back to the adding, 2 plus 5.29, hit enter, and then hit divide by 2. You should get approximately 3.645. We found one solution, or x-intercept, whatever you want to call it. Moving on to the subtraction, 2 minus 5.29, hit enter, divided by 2, and we got negative 1.645 for our other solution. Hopefully, as you worked through it, your answers match. Now, I realize this video is probably getting a little bit on the long side, but if you were thinking, oh, what would happen if this was a pretty square root? So let's just pretend. We're going to do some pretending. Ignore this chicken scratch here in the middle. You guys don't need that. Let's just pretend that this line had said x equals 2 plus or minus the square root of 81 all over 2. This is just a pretend. So you may realize that, oh, the square root of 81, I know that one. It's 9. So does that mean we're done right here? No. If I can go further, I can go further. And I guess I should note that these ones up here were approximate solutions. If the question says, give me exact answers, and you get something like the square root of 28, which is not a very pretty square root, then you stop here. But knowing the square root of 81 is 9, that means this is still exact. I've not rounded anything. There are no decimals in my calculator. I haven't rounded. So I can go to 2 plus 9 and divide by 2, and I can go to 2 minus 9 and divide by 2. 2 plus 9, hit enter, divided by 2, we get 5.5. And 2 minus 9 divided by 2, we get negative 3.5. Both of these are exact. When the number underneath the square root gives you a pretty square root, you have no need for approximation because you don't have to do any approximating at all. We never cut off any decimals. We only get exact solutions. So at this point, that's all the examples for me. I want you to go ahead and go back to Canvas, and I want you to work on the homework that is linked right there. And if you have any questions, just shoot me an email, and I will talk to you all later.